Thank you everyone for joining this webinar today. I'm Alexey, a professional services consultant at GridGain. And today we are going to discuss how to develop Apache Ignite applications that are easy to manage. First, let me motivate you and explain why it is important for the developers to care about monitoring and managing their applications. First of all, operating this application after it is developed, so the operation and maintenance cycle costs, they usually exceed development cost. And if you develop your applications that will be easy to manage, you can drastically reduce the operations cost. And that means you will reduce the total cost of ownership. And that means your product will be more competitive comparing to other products. So you will have bonuses and much more fun. Monitoring, it allows operations team to be proactive instead of reactive. And that means the time of outage will be reduced or eliminated completely. So you need to design your application to alert DevOps team before the application really breaks, if possible. And if possible, you need to design your application to automatically recover from failures. And all this management and monitoring, it is especially important for distributed applications. And Apache Ignite are distributed applications because such applications are very complex and usually they're mission critical. So most of our applications, Ignite application use cases, are actually financial use cases, very mission critical use cases. The plan for today is basically we are going to discuss how to develop applications which are easy to manage. We will discuss Ignite's monitoring and management features, and we will do some demo using the most popular monitoring tool. Okay, let's start from how to develop applications that are easy to manage. The goal, enterprise goal, is to have integrated monitoring. So the idea is to monitor everything in the organization using same set of tools. For example, on this picture, you see a typical monitoring dashboard consisting of many monitors of a large enterprise organization. Some companies use diverse set of disconnected monitoring tools, but this leads to increased costs to buy different tools, multiple tools. It leads to increased costs to learn those tools. You need to learn, instead of learning one tool, you have to learn, your DevOps will have to learn many tools. And operations costs increase when the tools are not integrated. Disconnected tools also result in duplicating alerts because each application will have some common infrastructure. There will be a lot of common infrastructure. And if you have disconnected tools, you will have duplicate alerts. So it's going to be a mess. So your goal as a developer, and by the way, the target audience of this presentation are mainly developers. We are not going to discuss different monitoring tools in details. So the audience of this presentation are developers. And your goal as a developer is to smoothly integrate the application you develop into enterprise monitoring infrastructure. First and second, to minimize time and effort to recover from a failure if your application fails. So how you do that? First, you develop a health model. Everything, we will discuss everything later in more details. Second, you instrument your code. Then you communicate your health model using a special document, monitoring specification. You use that to communicate your application health model to DevOps. And you make sure that this monitoring spec is a live document. You have to update it with every application upgrade and with every Apache Ignite upgrade. And it's better to make it part of your CI/CD pipeline. So let's start from the health model. The health model, so there are different different diagrams, different models, data model, architecture, design model, right? So we are talking about health model, how it is different. Health model describes components, only those components that can be configured and restarted or reset. Only such components. Health model also describes synthetic transactions. We will discuss later what that means. And health model describes health events. And the primary audience of the health model are DevOps. Developers create monitoring spec to communicate health model to DevOps. And this monitoring spec, it's a live document, yeah, as I said before. Okay, let's go deeper. In this presentation, in the next slides as well, we are going to use a sample application, which is called Business Rules Executor. So what this application does, it actually, well, it executes business rules using the rules engine. It's some engine from JBoss. It is a distributed application based on Apache Ignite. This application is deployed in Kubernetes. And the only application component, so this diagram, it shows multiple components, but the only component that application team actually develops is a Druze service. It is actually an Ignite service. It is running in Ignite as a fully replicated service. So this Druze service uses a Druze component called key scanner to monitor Maven repo with business rule artifacts and compile and retrieve these business rule artifacts and run them inside the session. The Druze service depends on Business Central. It's a component where actually users create business rules. So it extracts all projects from the Business Central. And this Druze service, it runs continuous query for caches corresponding to business rules projects. So it receives updates from the caches and it applies business rules to that data. This Druze service, it's a very computation intensive. It consumes a lot of memory. It consumes a lot of CPU resources, and that means we are also interested in monitoring of heap memory. This is where our cache data live. We are interested in monitoring heap memory. This is where Druze session live. We are very interested in monitoring GC because potentially this can create lots of GC pressure. And suppose that we are using persistence and yeah, we are interested in DB volume. So that's going to be the example that we will use. Okay, now each component, it has a health state. The health state, there are 3 states for the health. So first of all, the component is okay. First state is okay, green. We call it green state. Another state is a warning. That means the component is still operational. It basically functions properly, but the state is degraded. So at this point, DevOps already should do something to avoid complete failure. And component can completely fail. In this case, we call this critical failure red. The color is red. There are parent-child relationships between the components, and those relationships, they have cardinality. There can be either one-to-one relationship or one-to-many relationship. So in this example, all the components, they have one-to-one relationship except Ignite cluster. Our Ignite cluster, it's a cluster, and it consists of multiple Kubernetes pods. Yeah, as I said, this application runs in Kubernetes. So yeah, you show cardinality using this star UML style UML style diagram. Okay, and in this parent-child relationship, we propagate the state. So the state propagates over parent-child relationships in this way. If parent fails or parent degrades, then all its children degrade and all its degrade or fail, depending on the state. If one of children fails, then parent degrades, only degrades, because other children are still available. But if all children fail, that means the parent will fail. So that's how the state propagates over this diagram. And in this example, actually I use different colors. What I wanted to show on this diagram. So you see that the Maven repo failed, just completely failed, and that propagated to up to the chain via one-to-one relationships. So all the, Maven repo failing means key scanner failed, means Drull service failed, means Ignite server failed, JVM failed, the pod failed. But since there are many pods, the Ignite cluster, suppose that only one pod failed. That means Ignite cluster state is degraded. It's still operational, but it is degraded. And this orange state, it propagated to the application, to the top level application, which is business rule executor. So if Maven fails for only one service, that means in the end, the application state becomes degraded like that. A reminder, this is very important to remember that the final goal is to integrate your application into enterprise monitoring. So the large enterprise, it will have hundreds of applications, and your application is going to be just one of them. So the application developer, they hand over knowledge about application monitoring to DevOps, and DevOps, they integrate this application into enterprise monitoring system. So the goal is to show this business rule executor on the integrated dashboard, similar to that I showed you in the beginning. So this slide, it lists components in Ignite that could be considered as a health model components. So they could be configured independently and potentially they could be restarted. So, and they are actionable. DevOps can do something with them, right? So we are not going to read about those components. So go to Ignite documentation and just read about whatever you're interested in. Okay, let's discuss health events. Basics of monitoring and management are like this. Application has some logs and metrics that trigger events. Monitoring tool, it creates a monitor for every event. When event occurs, it changes state of corresponding monitor. Change in the monitor states, it creates an alert. And if automated recovery is available, it initiates automated recovery as well. So these are the basics of monitoring. Events, I mean, event is a very popular word. It's very overloaded. So what is specific to health events? First, health events are actionable. You need to describe only those events which are interesting for DevOps, that DevOps can do something with. Sometimes in the literature, they're called operationally significant events. For example, what are significant for some examples of operationally significant events? For example, Ignite cluster segmentation, JVM pause is too long, heap usage too high, Maven repo is unavailable or whatever. Example of non-health events. You can actually see those records, those events in the log file, but just don't document them for DevOps. DevOps are not interested in events they can do nothing with, right? For example, fail to parse SQL query. Yeah, logs potentially could be like overflowed with this kind of messages, but don't document them. This is not operationally significant event. Any kind of user input, it's also not significant for DevOps. The DevOps are not going to pursue users to fix their user input, right? So any kind of user input is not significant. Second, health events are specific. You must provide recovery actions for DevOps, to do something with those events. And those recovery actions, they should be unambiguous. They should not require any additional investigation from DevOps. Minimize or just avoid any if-else in the recovery actions. So this is just, there should be plain without any branches. Example of specific event, fail to connect to Maven repo. So in our case, you clearly know that we have a Maven repo. This is just one Maven repo. We are talking about specific application. It has only one Maven repo. So it's clear what happened. Another example of correct health event, malformed Maven repo connection string. So you already now know what is wrong with your configuration, not just configuration incorrect configuration, but malformed connection string. And examples of non-specific event, for example, HTTP exception. Well, I mean, Maven repo, it will manifest itself as a HTTP exception, but you don't need to just write HTTP exception. You need to specify what kind of HTTP exception. Sorry, you need to specify what kind of destination system failed, not just HTTP exception, but actually where we were unable to connect, right? We were unable to connect to the Maven repo. And also another example of bad event is malformed configuration. You don't want DevOps to just search entire configuration file. You need to specify what exactly is wrong with your configuration. What that means for the developers. In Java and .NET languages, we use structural exception handling normally, right? So that means don't handle generic exception. Always handle specific kind of exceptions. Furthermore, sometimes even specific kind of exception is not enough. For example, if you could not connect to Oracle database and you couldn't connect to MySQL database, you will get the same exception, SQL exception, or maybe something more specific, but still it will not tell you at once whether it's Oracle or SQL. But in a large enterprise, there will be different DevOps teams. There will be Oracle support team, and there will be MySQL DevOps team. And you need your alert to be directed to specific team. And that means you should separate fail to connect to Oracle from fail to connect to MySQL. If necessary, look up the exception chain if you can use it to separate exceptions, or maybe even parse exception message to understand whether it's from Oracle or from MySQL. But the idea is the event, it should be very specific and it should target specific DevOps team. Event collection. So in Ignite, we use three kinds of event collections. Log files. In this case, you specify a path to the log file. We use JMX. In this case, you specify object name, attribute name. We use SQL. There are some very useful Ignite system views that can that help you understand lots of details about your Ignite. Or you may have some application tables, and you may query some application tables to detect some event. If nothing helps, then you can always use some command line to automate. You can use a command line to get some event. This is just introduction, just concept. We will discuss why you need this later, but just always understand whether your event is historical or snapshot. So historical events are append only collections. There are multiple events in a collection. For example, log files or some historical SQL tables. And there are snapshot events. They always manifest single most recent value. For example, most JMX metrics are snapshot events, or maybe there are some snapshot SQL tables. This is important for automated recovery. We will discuss it later. Events are triggered when event expression becomes true. Event expression consists of operators, text operators like contains or matches, in case if you specify regular expression. There are relational operators, logical operators, so you can build complex expressions using logical operators. Your left operand is always implicit. This is actually the metric that you monitor, and your right operand is a literal value. For example, some log contains some text, right? Or our metric is greater than 95. Yeah, so some examples. Alerts. The idea is, the final idea is actually to alert, to generate an alert. The monitoring tools, it will end up with some alert. What is alert? Alert, it's either email, SMS, or phone call, or whatever channel is preferred inside the organization. And alert, it can also automatically open a ticket in enterprise ticket management system. you are not interested in alerts. DevOps are responsible for configuring alerts. So as a developers, you are not interested in this, but you just need to understand that in the end, your events, they will trigger alerts. The most popular kind of event is a single event. That means event occurrence triggers alert. That's it, very simple. There are repeated events. So this is when you trigger an alert after detecting n events, some defined number of events over defined time interval. This is a repeated event. Missing event. This is actually when you do not detect one event or many events over specified time interval. In this case, you open an alert. Correlated event. This is when you detect a sequence of different events over some time interval. In this case, you open an alert. And correlated missing event. So when you see some event but don't see other event over some time interval, you create an alert. So how actually important information about alerting. If your monitor is already unhealthy, there will be no alert. You need to reset. You need to reset your event monitor to open alert again. And so that means the health state is actually health specific, and health state is event specific. So the each event, it has its own health state, and components, they also have a health state. So if at least one monitor of a component becomes unhealthy, that means the entire component is unhealthy. So on this picture, I just showed some example. So first, we have here we have two events. We monitor two events, event X and event Y. So first, event X occurs, and we open. So these are all single events, simple events here. So when event X occurs, we open alert for event X. The next time event X occurs, there will be no alert because event is unhealthy. We do not duplicate alerts. But then event Y occurs. We open alert because health state, it's not for entire component. Each event has a health state. So even if event X is unhealthy, we still can open alert for event Y. Then we reset event X health state, either automatically or manually. The next time event X occurs, we again open event for alert X. But the next time event Y occurs, we don't open alert for it because it's still in unhealthy state. So yeah, this is important to understand. That means multiple events, they do not trigger multiple alerts. You have to reset health state to again open an alert. Automated health reset. This is very desirable for developers to design application to automatically recover from failure. So there are different kinds of health recovery. Health recovery on expression. That means we have some expression. When it evaluates to true, that means event. But when it evaluates to false, that event automatically resets itself. This is not applicable to historical event collections because we cannot monitor that event because the next event, historical event, it overrides the previous event. It becomes unavailable. So reset on expression is not applicable to log files. It's applicable to only snapshot events. For example, GMX metrics. For example, GMX heap is greater than 4 gigabytes. So when it becomes true, we open an alert. But if it eventually becomes false, then we reset health state back to normal. We can reset health state on another event. So for example, we have some cache store in Ignite, and that cache store went down. We detected that, and we generated an event that audit cache store is not available. But it is important for you to, as a developer, to actually automatically recover from this. So it would be great if you actually somewhere in a loop, in a cycle, keep trying to connect to cache store. And if that connection eventually succeeds, you generate another event. In this case, you will specify that some event state, health state, is reset by another event, and it will automatically recover. Another type of automated reset is a reset on timer. So for sometimes some systems, you know for sure that they become unavailable, but you know for sure that they will become available after some predefined time interval. In this case, you can specify for an event to automatically reset itself back to normal after some predefined timeout. If you cannot do automated health recovery, then you need to specify that your event requires manual recovery from DevOps. But do your best to automate recovery. So consider using Ignite critical failure handler. Just review documentation for details. But that handler, it already can monitor lots of abnormal scenarios, and it can, depending on the policy, you can specify policy what to do. Depending on the policy, you can recover automatically. If not, if this is your application specific code, then consider doing retry cycles in the application, as I said before. Not all components in Ignite allow to can be restarted. And if not, for example, Ignite services, continuous queries, they cannot be restarted. The services can be canceled, but not started again. There is no such API. There is no API for that. Consider investing some time to actually provide your application mechanism to restart some components, Ignite components that cannot be restarted using out-of-the-box monitoring tools. Yeah. Event schedule. Sometimes you know that your dependency has a maintenance window, and you don't want DevOps to receive alerts during maintenance window because that's normal, that's okay. In this case, you can specify a schedule. If you want, for example, if you want to alert 24/7, just say that. But for example, if you know that on the weekends you do maintenance, you don't, some other components, dependency of your application is on a maintenance, then just specify that you want to monitor your events only on Mondays, Fridays, or maybe only on Monday, Friday from 8 a.m. till 7 p.m. For every event, you have to share knowledge, what to do with it. DevOps, they know nothing about your application. This is actually you as a developer who know what to do with your event. So each event has a description explaining why the event occurred and what is the impact of that event. And specify recovery actions. They should be specific, avoid any if-else in that recovery actions, and just consider specifying such recovery actions that could be automated using some command line tool or maybe REST API or maybe something else. Some notes about log monitoring. Yeah, as I said, for logs, log is a historical collection of event. So it's not only about log files. It may be also about historical SQL tables, whatever. So the automated health reset state is not supported for log files. You need to write healthy event to signal that your application is recovered. Include unique ID to the log message. That ID would identify specific event, and that ID never changes. Whenever you upgrade your application, you may change application message. You may improve it, right? You may fix some grammar, but that ID will never change. So for example, your exception message might look like this, like on this example. The ID is in the beginning, in brackets, just to easier find it. Yeah, and it never changes. Be careful when specifying regular expressions. I myself saw several times when someone specified complex regular expression that worked perfectly fine on a small log file, but that would actually kill the server. It was using 100% of CPU on a server with real log files, large log files, like hundreds of megabytes long. And those are production servers, because monitoring agents, they run on production servers. And that means your monitoring just can kill production server. So be very careful with regular expressions. What is synthetic monitoring? So you write, sometimes we call it synthetic transactions. The idea is to proactively detect problems before real users detect those problems. Synthetic transaction is either subset of automated tests, non-intrusive tests, probably read-only tests, or consider adding a health check operation to your component, for example, to your service, Ignite service. Such a health check operation, it will just check health of all dependencies. In this case, you will just need to call this one operation, health check operation, to do synthetic monitoring. This monitoring, it runs against live production. So remember about that. And it runs periodically. Monitoring spec. That's the document that you share with DevOps to communicate your health model. The content, the monitoring spec consists of three sections: the components hierarchy, synthetic monitoring, and health events. You can do any kind, you can use any format to specify that health model. You can use document, whatever, but I recommend, so just from experience, I really recommend using a spreadsheet. For example, I'm using Google Sheets. You can use Excel spreadsheets. So for example, my spreadsheet consists of 3 pages. On the first page, we specify health model. It's actually pretty easy to draw such diagram in Excel. It's very convenient. Yeah, we already reviewed it, so it does make sense to review it again. The next page, it basically describes synthetic transactions. So synthetic transaction, it's like a test. It consists, for example, we have ensure rules service runs a synthetic health check, whatever. Yeah, we are not going to consider that, we are not going to review specifics about the synthetic transactions, but just remember that it's just a test. It has a title, it has a description, it has setup, it has execute action, and it has verification. That's it. And the third page, it actually describes the events. So all the event attributes that we reviewed before, they are here. So each event, it has a unique ID. Each event belongs to some component. It has a title, it has a schedule, it has a collection type. So depending on the collection type, you have different collection specs. So for example, for log files, you have you specify a log file. For JMX, you specify object and attribute, and so on. For SQL, you specify query. You specify trigger expression as part of the collection. Then you have monitor section. So you specify the kind of monitor. It can be either single, repeated, correlated, missing. Depending on your event, if your event is repeated, if your event of any kind except single, you need to specify time interval. For repeated events, you have to specify number of events. For correlated events, you need to choose other events from the spreadsheet, sequence of other events from the spreadsheet. Then on here, you specify health. The health, there is a severity, there is a recovery type. It's either manual or by a health event, or by timer, or by expression. You may specify timer duration for timer events, and you need to specify health event for automated recovery. So for example, event 10.105 on this diagram, it has automatically recover on event 10106. You specify description, and you specify unambiguous, clear recovery steps, how to recover from each failure. You need to have automated tests to test abnormal scenarios. And I'm talking about end-to-end tests or system tests or integration tests. It's not unit tests, it's end-to-end tests. And in that test, you have to check the event. That event was really generated. So if this is log file, you need to check that event is written to the log file. If it's some JMX metric, you just need to get that metric, that real metric, and ensure that it is really working. You need to develop synthetic transactions. Yeah, just as a reminder, it's either subset of automated tests, or you just add health check operation as a synthetic transaction, and make it part of your CI/CD pipeline. So you probably don't need to run it on every commit, but you definitely need to run it on every operation before application is upgraded or before Apache Ignite is upgraded. Monitoring and management tools. You as a developer, you are not much interested in which tools are used, but just for your reference, I know for sure that this health model, which I described here, is supported by these three tools: Zabbix plus Grafana, Prometheus plus Elasticsearch, Logstash, Kibana. Prometheus is a great tool to work with metrics, but it cannot work with logs. So you need to add Elasticsearch to analyze logs, Logstash to store logs, and also it makes sense to always add Grafana for visualization. And Microsoft System Center Operations Manager. It's a very sophisticated tool, but it's very expensive. But it's going to be obsolete, I think, soon. It is moving to the cloud, and it will be called Microsoft Aquila. Currently, Microsoft Aquila is in preview phase, but probably in the future, you will use Microsoft Aquila. It's going to be available in Microsoft Azure. Some words about Apache Ignite health model. There is no conceptual model described anywhere for Apache Ignite, so it is not available. What I described here would be great to have for your applications, but Apache Ignite doesn't have it. Yeah, it would be great to have something similar for Apache Ignite. So that means, since there is no Apache Ignite health model, that means you need to include Apache Ignite health model, subset of Apache Ignite health model to your application health model. And yeah, you don't need to include, you don't need to completely describe Apache Ignite. You need to describe only those events which are applicable to your application. Another things to consider, Apache Ignite does not have unique event IDs. And I personally saw multiple times when monitoring was lost. So yeah, the monitoring team set up some monitoring by parsing Apache Ignite events in the log file, and they fixed some grammar. I mean, Apache Ignite developers, they fixed some grammar, and monitoring stopped working. But that was never tested, and the problem was discovered when actually it manifested itself. And then the user found that actually the monitoring just did not work, right? So we already discussed how to deal with that. You need to retest your monitoring with every Apache Ignite upgrade. Ignite components restart. Yeah, so just go to the documentation. Yeah, you can restart components using command line, using SQL kill command, or using REST API, using JMX, or just using application programming interface. So yeah, go to the documentation. It's all described there. But just remember that restart is not available for many Ignite components. Like continuous queries cannot be restarted, services cannot be restarted. I mean, cannot be restarted. There is no ready-to-use tool for that, right? So you may consider adding this restart functionality to your application. For example, restart your Druze service without restarting the entire node, right? That would be useful. Some words, the most popular question which I personally have from Ignite users is about configuration. This is just a slide which highlights how complex Ignite configuration is, Ignite node configuration is. So the configuration settings have different lifetime. It is either static and defined in Spring XML or .NET app config or in the code, right? Or it can be dynamic. For example, you can dynamically create caches and indexes. And remember that if persistence is enabled, then whatever you create dynamically, it will become static. So it will be available after restart. But if there is no persistence, it will be lost. So you will have your static configuration after restart. Yeah, some other settings like cluster state, ID tag, statistic status, they're also dynamic. And there is a different scope in that settings. So some settings are applicable to entire cluster. They are merged. Whenever you start your node, your settings are merged with cluster settings, right? For example, caches, services, binary configuration. And there are settings specific to each node, like work directories, data region settings, well settings, thread pool sizes, and so on. So just always understand Ignite configuration settings, communicate this to DevOps. Yeah, another popular question is how to restart the node. Yeah, in Kubernetes, first deactivate the node if persistence is enabled, and then delete that pod. We are very quickly going to show you some slides. So these are screenshots from a real user, from a real Apache Ignite user. The monitoring is built with Zabbix and Grafana. So for example, this is the Ignite dashboard. This is a topology. We can monitor discovery message queue size. We monitor TCP communication queue size. We monitor striped executor queue size. We monitor GC poses. We monitor long-running transactions. So, for example, as you see on this diagram, some transaction is taken more than 1.5 an hour, which probably is a problem, right? We monitor checkpoint time. Disk space. We have a persistence enabled, and we monitor disk space. We monitor heap utilization. Okay. So what I wanted to share in this webinar is that this is the developer's responsibility to develop health model, to instrument the code, and by instrumenting the code, I mean designing automated recovery and writing appropriate events to the log file or somewhere else, up to you. You need to create monitoring spec to communicate this knowledge to DevOps. And the monitoring spec is a live document, always updated with every Apache Ignite release, with every application release, added to your CI/CD pipeline. Yes, that actually adds additional development costs, but these additional development costs are much smaller than the reduced total cost of ownership that you will get in the end. This is why it is important. And that's it for today.
All right. Thanks, Alexey. Thanks, everyone. Goodbye.
Thank you. Bye.